Okay, dear students, today I am making this video for the students, those who could not attend the Zoom call. So here we have discussed about today's swing equation. Now the term swing, swing means here it means the swing of the rotor angle. So for knowing this swing of the rotor angle, we should initially know about what is rotor angle. Now that rotor angle is the angle difference between the rotor axis and the stator magnetic field, or rotor field axis and the stator magnetic field. In this diagram, this delta is the rotor angle. So for knowing these things, we should recall our previous class, which is your this one. This is the power angle. This is the power angle curve. So power angle curve we have discussed in the previous class. This is basically the relation between the power and the angle delta. Angle delta. Now here we have derived the relation between power transfer from this side to the infinite bus, and how we have done the procedure is already explained here. And after derivation we have seen P is EB by X sine delta, and Q is, now what is P? P is the active power transfer from the generator to the infinite bus, means it is flowing from the side to the side. The current is flowing, also power is flowing in this way. And this we have taken it as positive. Similarly, if the current is flowing from this infinite bus to the machine, then that power we can take it as negative. Now say the equation here. What is E? Is the induced EMF and the synchronous machine. B is the infinite bus voltage. X is the total reactance of the synchronous machine and the transmission line. Delta is the here load angle or rotor angle. Now here see, if we vary this delta, we will see different values of powers. Suppose I make it 0, then whole power will be 0. If we make it 90, sin delta is 1, means maximum. So this becomes the maximum power. Similarly, if we make it 180, then this will come 0 again. Again, if we increase it to 360, this will be again 0. So if we plot the P for different values of delta, we'll get the power angle curve. Now here it is the graphical representation. Here you see for 90 degree, this is maximum 180, again 0, and this side it is coming negative. Negative means this is the motoring action. If you, as I said, if we see this one, current is going in this way, means negative, so it is absorbing, the machine is absorbing from the system the power. That's why it is motoring action. Now when it is generating, the power is positive, so that's why in the curve it was written like this is generator action and this is motor action. So now come to this one here, the swing equation. Now initially under normal condition, the angle between this rotor magnetic field axis and stator magnetic field axis is constant when there is no variation in the load. Now what happens if there is sudden load change? What will happen? The speed of the machine will change. And due to that, speed of the machine means speed of the rotor. Speed of the rotor will change means that delta will change. So all these are rotating. This is rotating, this is rotating. So that should be measured with some reference axis. That's why this reference axis is taken here. Reference axis is taken here. Now you can see when just a minute. This is used. The swing equation is used for actually transient stability studies. Now, what is transient? When there is sudden change in the system, any fault occurs, then what will happen? The machine output power will change. According to that, machine behavior will also change. So, for to study that behavior of the uh, synchronous machine, the swing equation is required. This swing equation will actually give you the relation between the variation of delta means the rotor angle with respect to time. So that is called swing equation, and that equation will give you the relation between this delta and time. So that is represented with this curve, which is called swing curve. Here you can see we have shown the two curve. One is this one, another is the straight one. Now when time increases or time passes, if the delta is increasing and increasing, the system becomes unstable. And similarly, when delta increases, you see here, till this delta time is increases, delta is also increasing. After that time, once time increasing, but there is delta is reducing, means the system will be stable after some time. But in this case, what happened, the system will not be stable. Why? Because if you see this curve, as we increase the time, delta is increasing and increasing. So it is not a stable system, it will be an unstable system. So that actually whether the system is stable or unstable, that we can decide by doing swing equation. Now let's